Okay, so today we're covering section 6.1 and a little bit of section 5.4. We're getting near the end, guys. Getting near the end. So section 6.1 is about area between curves. We'll just generalize it that way. Okay, so we know a couple of things. I'm just going to jot over here some things that we need to remember. So these are the ones that came out of the prep video. So we know that if f of x is entirely below the x-axis, then its integral is also negative. Okay, so we know that that's true. If it's entirely above the x-axis, then we know that the integral is positive. And then we also know that if we're trying to find the area between two curves, we want to look at finding the area would be equal to whatever the upper curve is minus the lower curve dx. Okay, so that's what we know so far. So so let's think about this then. This is sort of one case where you're comparing it to the y-axis. So if you wanted to, you can consider this to be two curves as well. F is one curve and the y-axis is the other. So this is sort of a subset of this, if you want to think of it that way. For here, what is the important piece of information I need to know? What is my breakpoint in terms of how I set this up, how I know whether it's positive or negative? It's where it intersects the x-axis. So when I'm graphing this, what do I absolutely have to graph? The intercepts. I can't know where it's above the axis or below the axis if I don't know where it goes through the axis. So the important thing here is that we have to graph intercepts. Does it matter how perfect the graph is beyond that? It doesn't really. So if I know that my intercepts, say, are here and here, it doesn't matter if I draw the graph that way or that way. It kind of doesn't matter for the setting up the integral because we know where it's positive and negative. So the perfection of the graph, this is not chapter 3 where we are finding the max, the min, and concavity. This is a very brief sketch for these. This is just, so if you know the shape and you know the intercepts, and then what would we need to know here? How do we know where a curve is the upper curve or the lower curve? Where is that breakpoint going to happen? If this is F and this is G, here F is higher, but over here G is higher. G is the upper curve. Where does it change? Intersection points. So we need to find intercepts and intersection points. That's the main thing that's driving our sketches. We don't need, beyond that, this is good enough, just kind of a hand wave sketch, good enough. So we need intercepts and we need intersection points.
Do we actually have to graph?
Yes. Unless you happen to know. Okay, so here you go. Find the area between
You know how it tells you the domain?
hang on, x cubed from, I'm just trying to get this problem, from x equals minus 3 to x equals 1. So without a sketch, do you know where it's above and below the axis?
Can you just...
This one you do. So what about this one? Yeah, right, no? Right, now you don't know? Wait, you don't know? Oh, come on, you don't know? Yeah, we don't know. Okay, so the point is, for the really easy one, yes, you can know that in your head. How many of those am I going to give you? Yeah, like not all of them. So yes, you do need to sketch. So get in the habit, just like how do you know if it's a max or a min? What do you have to do? A sign chart. You can't know until you test. Same thing here. This is kind of, the sketch is very analogous to a sign chart. You're trying to see where it's above and below, where it's upper and lower. So yes, you must sketch. So let's look at this one. This is an easy one. We probably don't have to sketch, but let's sketch it just so we can graph it out. So if I wanted to find the area from between this curve, oh, I didn't say that, and x-axis, from -3 to 1. So let's do a sketch. You need to know the general shapes of quadratics, cubics, lines. I don't think we're going to do anything much fancier than that. Most of what we'll do will be polynomial, but you could have a ln or an exponential. Those are curves you should know as well. So here, what do I know cubic looks like? Something like that. Okay. And I want to go from, say, -3 to 1. So before, on the prep video, everything we did, the curve was either entirely above or entirely below the x-axis. So that was easy. Just you knew it was either going to be positive or negative. That was fine. So here, some of it is below and some of it is above. So any thoughts about what we need to do? If I just integrate from -3 to 1, what will happen? This will be negative, and then I'll add in some positive. So some of the positive area will cancel with some of the area below the axis, so I'm not going to get a total area. So I can't do that. I can't go from -3 to 1. So what could I do?
-3 to 0.
I could break it up. Do this piece, which I know is negative, and then separately do that piece. And then add the positive, make this one positive and add. So yeah, that's what we're going to do. So that one piece that we need to remember over here is that if we go from A to C, we can break that up and go from A to B and B to C. That's okay, because we'll end up with the same thing. The problem is when we do that here, I mean, that would be a reasonable thing to do, but if we start doing that here, we have to be careful. We can't just do this. So this is not equal to, that's not equal to the area if it's above and below the axis, because if I just integrate straight through, I'm going to get some canceling. So what do we do instead? So the area we're looking for, you can do it one of two ways. You can say, well, this is area 1 plus area 2. I want to say area 51, but okay, so it's area 1 plus area 2. A few smiles early in the morning. That's nice, isn't it? All right, area 1 and area 2. So then I could split them apart and say, okay, area 1, let's call this one area 1. So if I go from -3 to 0 of x cubed dx, right, that would be the first area. What do I know about this area? It will, the integral will be negative. So if I just do it like this, I will get a negative area. So how do I fix that? I can just put a minus sign on the front. Or you can get area, integral 1, if you want to call it that, get a negative number, and then at the end just make it positive. Because the area is the same as the integral, just a different sign. All right, so let's go ahead and work this. So we're just going to do the antiderivative and all the parts. So negative, raise the exponent, divide by, from -3 to 0. I'm going to pull the -1/4 out front and then just say 0 to the 4th minus -3 to the 4th. If you like, you can carry the 1/4 with everything. That's fine too. That's your choice. So -3 to the 4th, anyone know that? You know that. -3 to the 4th would be -3 squared squared.
Whatever 27 times
3, or this way is even faster. -3 squared is 9, 9 squared is 81. So -1/4 times. That's not Common Core, that's just common sense.
Same thing.
Okay. All right, so 81/4 is what we get from this first piece. Do we expect the second piece to be bigger or smaller?
Was 1.
I'm only going as far as 1. I'm thinking it's going to be much smaller, right? It's going to be the equivalent of this little piece over here. So that's just a good check. When you're going along doing the work, it's okay to look at it and see if it seems about right. That's okay. All right, so this is area 1. Area 2 then is going to be this piece over here. So area 2 is just going to be the integral from 0 to 1. I already know that the integral will be positive, so that means I don't need to negate it. All good. So 1/4 x to the 4th, 0 to 1. So that's 1/4 when I put in the 1 minus 0, so 1/4. So all together, my area then, I'm going to add up this part from A1 and that part from A2. So altogether 82 fourths. 82 fourths. 41 halves. And you can leave it that way. You can make it 20.1 if you're 20.5 if you really want to, but you don't have to. So this is one way to do it, where you simply just do one area and then you do the other area and then you add them at the end. We can also set this up in one whole line. I'm going to show you that. It really doesn't matter which way you do this, just so long as you keep track of the pieces. So the other way to look at this is right here. I don't have to separate out the A1 and A2. I can just say this is A1. Whatever is below the axis I negate, and whatever is above the axis I don't. So you can just run it together in one line. It doesn't, either way is fine. So the important part here is, what did I need to know in order to split up the A1 and the A2 pieces? I needed to know where it goes through the axis. This one was obvious. They won't always be. So how do we go about finding x-intercepts?
Finding zeros.
Yeah, finding zeros, so you're going to set y equal to 0. So if I had something like this, y equals x squared minus 4, and I wanted to find the 0, remember you just set it equal to 0 and factor, quadratic formula, complete the square. Who really wants to do that? Okay, so that's one thing. All right, so now let's look at... All right, any questions I can answer? Here's some aha moments.
Wait, okay. So I know, I should already know this, but, okay, so when you plug the integral in, you always subtract the top from the bottom, right?
But we don't have a top and bottom curve in this scenario.
Okay.
So we have two scenarios. One is where we're just comparing to the x-axis, and one where we're comparing two curves. And right here, we really only have one curve.
Mm-hmm.
Although if
Oh yeah, so you're just adding both of them, but yeah, okay.
But because this one's going to be negative, I have to negate it.
Okay.
All right, so let's look at another one. Let's look at between two curves.
Wait, what was that? Why? What was the...
Oh, that was just reminding you how to find zeros.
Oh,
You set it
okay,
equal to
yeah.
0, you factor quadratic, whatever. Okay, so let's look at this one. Because here's another way to ask this. Find the area. So in the first example, I gave you a curve and the x-axis, and I gave you the limits, right? I said from here to here. You can also say it this way. Find the area bounded by y equals 2x plus 6, y equals 8, and x negative 1 to 2. Does everyone agree I have two curves going on? I have this one, which is actually a line, and this one, which is another line, but a horizontal line. Do you know which one is upper and lower? Right off the top of your head, right now. He says yes. Which one's which?
Y equals 8 is the upper.
Okay.
And it starts at plus 6, and then the slope is 2.
Okay,
I think.
you're right. And so now, is it the whole way? I mean, at some point they're going to intersect, right? Do we know exactly which one's upper and which one's lower, and exactly over which? So what are we going to do?
Draw it.
Draw a picture, right? I recommend drawing a picture just like I recommend doing sign charts, like you recommend when you're doing a word problem, writing out what you're trying to find and what you know. You lay it out. Don't jump to the answer. Lay it out. So if I know I'm going to graph things, that means I know I'm going to need to find x-intercepts and y-intercepts for that matter, and I need to find intersection points. So before you do the graph, I recommend that you do that work first, so that when you go to graph, you kind of hit all the points. You don't have to regraph. So let's start with the easy one. Y equals 8. We know what that is. We can draw that. That doesn't do anything. Does this have? So the line has a y-intercept of 6. X-intercept. Not 3, close. Anyone? Hello?
2.
How about 2x plus 6, set it equal to 0. Negative 3. So over here, so something like this, -3. We think it's going to go through like that, but before we actually put the intersection point there, let's find the intersection point. How do you find intersection points?
Set them equal.
Yeah, just set these two pieces equal. So now I have 2x plus 6 equals 8. X equals 1. So something like around here, I expect it to cross. So it's worth having some points on to make sure that when you sketch everything, you kind of hit all the important points. So, it's pretty good for 8, whatever it is in the morning. Yeah. Okay. So it says area bounded by. And so I could also have written this way. I could have written this as 2 more lines. You could write it that way as well. So -1, that would be this line here, and 4 would be way out here. In fact, let's go back to what it was, which was 2. That was the original problem. We'll just make it a little bit easier. So where is what I need to shade in the area bounded by? So I've got this area here, and then this area here. Does that look right? Do the top and bottom curves stay the same? Coming along here, what's the top curve in this part? Y equals 8, and then coming over here, the top curve is the other one. So it's kind of hard to know until you sketch it out. Okay, so once we've sketched it out and we know...
Wait, is that going to be negative since it's like under, or does it have to be like under the x-axis?
If you do upper versus minus lower, it's always positive.
Okay, all right, but I was talking about like if you're finding the area, so the area would have to be under the x-axis for it to be, or for you have to
For it to be
negate
negative.
it.
Yes, yes. And the reason for that, when we're talking about area under an x-axis being negative, you can think of the x-axis being the top curve. So this is not pertaining to this problem. But so if that's the top curve, and you say the top curve, y equals 0, minus whatever f of x is, and there's your minus sign. Comes over here. Yeah. Okay, all right, so let's look at this one. So I'm going to erase, make a little more space. So let's go ahead and set up our intervals. One of the things, again, it's fairly easy to make just easy computational mistakes. So on the test last time, I had people just set up the integrals and not actually finish them. So that's the important part that I want to see here is do you know how to set it up? The integration part I may test separately just so that it gets frustrating, I know, when you're trying to work through a problem and it's not, you made one mistake here that doesn't pertain to the calculus. So, all right, so let's set this up. So we know that we're going to integrate from -1 here all the way to the intersection point. That's where they flip. So I'm going to integrate from -1 to 1. And in that area, which is the top curve?
8.
This one, the y equals 8 line is the top curve. And when I say top curve, I mean literally vertically above. That's what top means, or upper, literally above. So it's going to be 8 minus the lower curve. Please do include parentheses anytime you're subtracting. And then I'm going to keep going because there's more area that's enclosed. I'm going to start here at 1 and go as far as 2. And now which is the upper curve?
Y equals 2x.
The y equals 2x. Does everybody see that that's the upper curve?
Can you do that again?
Yes. Okay, so start from the beginning or just that piece?
Well, just that piece.
Okay, so if I'm going from here, I know that this happens at, I found that intersection point was at 1. So I'm going to add here from 1 to 2. Now if I'm looking from 1 to 2, so I'm looking just in this right here, which curve is the upper curve? Which one is vertically, physically above the other? And that's this one. Because if you draw a line down, right, there's the bottom curve. Okay, so here would be 2x plus 6 minus 8. So the important piece here is the intersection point. I asked which was the top curve. Well, yes, y equals 8 is the top curve part of the time, but not all of the time. And so it's important to sketch it so you know. And so how do you know where they flip-flop? Right here at the intersection point. So we have kind of two separate scenarios here. One is above and below the axis, you're looking for x-intercepts. And this is above and below, you know, which curve is above or below, and here you need intersection points. Yeah?
You closed the parentheses in that, right? In the second one. Second piece. the 2x plus 6.
Oh, I didn't do a parenthesis there because I was only subtracting an 8, but yes, if you wanted to, you could do that. Yeah, that's fine. Extra parentheses are never a problem, as long as you keep them straight. Okay, so do we want to finish this one altogether, or do you want to set up another one?
Set up another one.
I think the integration part is easy. Particularly, most of the problems are going to have functions this simple, so the integration would be, we don't tend to combine reverse chain rule with area problems. So the area problems will have easy integration. So, all right, so let's do another one. So now I got to make up one. It's a danger. All right, so let's look at this one. Find the area bounded by oh, I'm trying to come up with one that will come out nicely. And maybe, let's see if it's actually bounded. It won't be bounded, wait.
Is it one of the ones in the basic?
Yeah. Yes,
Like,
yes, give me,
where is y equals negative 2x plus 8,
yeah.
comma, y equals 12.
I need
And
something
the
with a, I
remaining
need something with a,
Oh.
hang on a minute, wait, I need something with a quadratic in it to do what I want to show you. Hang on a minute. I'm sure they have one in here. What I'm trying to get is something that's going to look like this. So you have this curve here and this piece here. That's what I'm trying to do. We have multiple intersection points, but that's just not happening. So let's go with this one. Let's see if that will give us something. And if not, we may have to tweak the problem. So bounded by those two things. I think it won't actually be bounded, but we'll check it out. Okay, so bounded by. I didn't give you any limits on x, which means that I'm looking really at intersection points. So if I wanted to, so I know I'm going to need to find intersection points, so let's do that. So I'm going to set the two y's equal. So x cubed minus x equals x. Oh yeah, this will work. Oh yay, good for me. I'm so excited. Okay, so x cubed minus 2x. Oh, it won't. All right. I'm going to make this a 3x. Oh, I'm messing with the problem. This could be bad. All right, so that's a 4. Okay, so how do I solve this? It's a polynomial, right? So factor out everything you can first. Oh, look at me. Yay, that's good, right? Okay, keep factoring. So what do we have? We have 3 intersection points. This one gives us 0, -2, and 2. All right, so you have to set each piece equal to 0. If this had been a number, just like a 3, and you would say 3 equals 0, that never gives you anything, so that would just not have anything to give you. But so in this case, I have 3 intersection points. This looks like this is a cubic, so it's kind of it kind of goes like this, and this is a line. All right, so let's go ahead and start. Let's do a sketch. Where does this go through? Where does this go through? I need to sketch this. I need more. So this one, if I try to find intercepts, those are easy intercepts. Does everyone agree that's true? So here, and here, and here. And then this one is just going to go straight through it's just a line, right? It goes right through the origin. So this is going to look something like this. And this is going to look something like, I know that the slope is off, but it's going to look something like that. So I had 2, and, well, that should be way over here, but -2. That's as good a sketch as you need. Okay, you don't need anything fancier than that. So you notice that everything's not lined up perfectly, that's okay. Did I hit all the important parts? I got the intercept, and I got the intersection points at 2, 0, -2, 0, and 2. Can you guys do the sketching part? Or would that have been hard? How many people could have done this sketch, do you think? You're not, the camera doesn't see you, so, anybody?
Why did I calculate?
If you had a calculator, yes. So, and I'm okay, there are times where I want you to sketch by hand, and there are times when a calculator can help you. The important thing is that I want to see this work. I want to know that you know that you're trying to find intercepts and intersection points. I know it's a cubic. I know cubics go like this, and then they start to do like that. That's what cubics do. So I just happen to know that. Okay, so we've got the sketch. That may be the hard part. So now let's look at how we set up the integral. We're trying to find the area bounded by. So where is that area? Is there any bound out here? This goes on forever, right? So this is not bounded. Bounded means you can draw a line all the way around it. So I get this piece and this piece. Okay, so we need to do upper versus lower. If it helps you, start here and draw an arrow down, right? Start here, draw an arrow down. That tells you where the top is and where the bottom is. Okay, so if we're going to, so what are our limits for the first one? I go from the intersection point all the way to 0. I think that's right. So -2 to 0, which is the top curve in that case. X cubed minus x. And the bottom curve minus, you're going to subtract off the 3x. So that's the first piece. And again, if you want to label them A1 and A2 and do them, you know, here's A1, add that up. Here's A2, find that out, and then add them at the end, that's fine. And then we're going to add to that, what will our second integral look like? You do that one, set that one up.
0 to 2.
Say again?
0 to 2.
0 to 2?
This is the thing I don't get. Like, I don't really see a point of graphing because, okay, once you find the x's, you go from -2 and then there's 0. So we found x equals -2 and 2 and 0. So we go to -2 to 0 and then 0 to 2, and then
Okay.
you don't have to do that, right?
All right, so now do the problem from the beginning without looking at that. Would you be able to?
Yeah,
Yeah.
because, okay, like I was just saying, like, okay, when we found, like, the x's, when we equaled x cubed
Okay, I
minus
just
x
put a negative and a plus. Now can you do it?
Here, wait, can I go to the front here?
I think the problem is that it's, once you've seen the picture, it's easy to do it. You really can't do it without a picture. You really can't. Unless you just happen to know where all of these intersect and you can hold it all in your head.
Like
In which case you're not communicating to me your solution. So remember, math is not about the answer. Did I say that? Does that puzzle anybody? Math is not about the answer. Math is about the process. So that's why on a test I'm giving partial credit because I'm looking at the process. Yeah.
Also, could you just easily do like a sign chart?
You could do a
I
sign
know, like,
chart.
you found your intercepts and then found like
Yes. Which one's
what's
above and below? Yes, the sketch is really very much like a sign chart. A sign chart is a compressed XY axis. So if you can, it's not a method I'm going to recommend to everybody, but yes, absolutely. If you can piece how they fit together, you can do a sign chart instead. Yeah. Where you just subtract them and just see where one's above and below, and then right. You
Right.
can do that.
I mean, as long as you have something like that simple,
You have to
can
have-
just plug in a random number.
But you need to
in
know
between
the
the
intersection
intersects.
points to know which one's higher and
then just put
lower.
like,
Yeah.
if the intersection point is
Right.
a 2 and a 0,
Right.
then I can just
So
plug in
the
one,
thing,
but
the
this
thing
is
that you
above here.
must do is you must justify which is the upper curve. So however you want to do that, you have to be able to justify which one's the top and which one's the bottom. So doing it in your head is not justification. So you need a sign chart, a sketch. So what